So in this next video on sequences, we'll be looking at quadratic sequences. So in this video, we're going to carry on from what we looked at sequences, in particular linear sequences, and move on to quadratic sequence. Now, the key thing to be able to know is the fact that when you're dealing with sequences, either at Key Stage 3 or at GCSE level, there is really going to be no indication what type of sequence it's going to be. So it's really important that you're able to spot what is a linear sequence and what is a quadratic sequence going to look like. Now, in order to spot a quadratic sequence, so a sequence is likely to be quadratic when the difference between each term is not the same. And it's not guaranteed to be quadratic, but the chances are that when asked to find the nth term of a sequence that is not linear, up to GCSE, it probably will be quadratic. And so just add that word there, just to make sure that your notes are on point. So as an example of what I'm actually talking about, so if I just get a pen, so for example, if I had a sequence that had 7, 11, 15, 19, 23, so here you can see that the difference between each of these numbers is +4, and that continues all the way. And it's always important that you don't just look at two consecutive terms, so you don't just look at the first one and the second one, you look at the string of sort of numbers in the sequence to make sure that the numbers are the same. We'll see what the difference is. So this is what we'd call a linear sequence, as the difference between each term is the same. Now if I ended up with a sequence that had let's say 2, 5, 10, 17 and 26, you can see here that the difference between the first and second term is +3, the difference between 5 and 10 is 5, then it's +7, and then it's +9. Now, if this was a quadratic sequence, and this is another way which we'll go into when we go on to looking at finding the nth term of a quadratic sequence, is that, if I just move that up slightly, is if we look at the difference between each term and term, on this second sort of string of numbers, we can see that what I like to call the double difference, or the difference of the difference, is +2. So you can see here that as the double difference, or the difference between the difference, I'd like to call, basically what it is the same, then this is a quadratic sequence. Now obviously you can get different sequences, you can get cubic sequences, you can get Fibonacci sequences, so it's really important you establish, but whenever you're asked to find the nth term of a sequence that obviously isn't linear, 9 out of 10 times it's going to be quadratic up to the level of GCSE. So let's have a look at the first part of this video, which is looking at generating terms from a quadratic sequence. So in these questions, what we're asked to do is find the first 5 terms of the sequences, and we'll be given the nth term for this. Now, when you are given things involving square numbers, now in terms of n squared, I should say, that it might appear on the calculator paper, and there is a way you can do this on a calculator, but I'll show you another video of how to use your calculator for this. But more often than not, a more challenging aspect would be to do this on a non-calculator paper. Now for each of these questions, what we're asked to do is to find the first 5 numbers of the sequence. So we're asked to find when n equals 1, 2, 3, 4 and 5, and these are the numbers that we're going to substitute into the nth term of each of these particular questions. Now, as a rule of a tip, I would strongly recommend that if you're not using a calculator for this, is to look at the n squared numbers. So n squared is 1 squared, which is 1, 2 squared, which is 4, going through a common mistake that most students make there is talking and writing at the same time, 3 squared is 9, 4 squared is 16, and 5 squared is 25. Now just writing this list of numbers will help me when it comes to substituting numbers in, particularly on a non-calculator form. So if I just colour code this first one as A, so here we're looking at when n equals 1. Now typically what you need to do is substitute n equals 1, so 1 squared plus 3 is going to give me 4, 2 squared plus 3 is going to give me 7, then 3 squared plus 3 is going to give me 12, then 4 squared plus 3 is going to give me 19, and 5 squared plus 3 is going to give me 28. And as you can see, I've written the terms vertically there, so what you might want to do is write it horizontally. And there is my first 5 terms. Now, obviously, with regards to the next one, so let's get a different colour pen, so let's do this one in green. So with B, now you can see that I've already written, now the key thing with regards to 2n squared is, remember, bit mass. So 2n squared means 2 times n squared, not 2n, work that out, and then square it. So it's really important that you recognise that 2n squared is not the same as 2n squared, which again is a whole different topic. So let's just get rid of that. So once we've got this, so basically what I need to do is square each of the numbers 1, 2, 3, 4, 5 and then multiply them by 2. So if I look at this red solid bubble, I've got my list of n squared numbers. So from this, all I need to do is double them. So here we've got 1 times 2 is 2, 8, 18, 32 and 50, and there is my first 5 terms. Now if you look at C, let's use blue for this one. So for C, again, what I'm going to do is I need to substitute the numbers in. Now if you were using a calculator, then what I'd recommend is you write 3, then write 1 squared minus 10. Now if you type in your question like the sort of expression into your calculator like this, it will give you the correct answer. Then for the second term, I'm going to swap n for 2. Then I've got n equals 3. And then n equals 4. Then n equals 5. And you can work out, so if I was going to do this on a calculator, anything that involves an n, I would strongly recommend you put that in brackets. So if I was working with B, I'd put brackets around that and then swap n for 1, 2, 3, 4, 5 respectively. Now again, obviously we can use the numbers in the red bubble because obviously it comes in handy. So basically what I'm going to do here is I'm going to do 3 times 1, which is 3, take away 10, which is minus 7. Then 3 times 4, which is 12, take away 10 is minus 2. And then if I repeat the process, I'm going to end up with 17, and then 38 and 65 for the remaining 3 other terms. And then for D, so again, let's use orange for this one. Now this one's a little bit more complicated. So for this one, I strongly recommend that one way of doing this is to split up this into, let's say, columns to make your life a little bit easier. Now again, I'm just showing you several ways in which you could work through this. So if I had n equals 1, 2, 3, 4, 5, and again I should really have set this out a little bit better. Now the numbers on the n column are just my term that I'm looking for. So I've got 1, 2, again these lines are dreadful. There we go. So n squared, and again if I just we'll use red. So 1 squared is 1, 2 squared is 4, 9, 16 and 25. Now then I've got to do 3 times the n number, so that's 3, 2 times 3 which is 6, 3 times 2 which is 9, 4 times 3 which is 12, and 3 times 5 which is 15. And I'm adding those because I've got a plus there, and then I've just got to add 1. So when you have got quite a complicated formula to substitute in as we have here, then you might want to do is set this up into separate columns and work each part of that nth term separately. And then all I've then got to do is just simply add the numbers up, in which I get 5, 11, 19, 29 and 41. And again, all different ways of you substituting to find the first 5 numbers. Then finally for E, which we will do in whatever colour this is, it's like purple, it is purple. So here, now again, with algebra and you see brackets, the very first thing you tend to do is expand it, and that's usually 9 out of 10 times what you should do first. Now for this, it just makes our life a little bit easier if we just use it mentally. So here we're going to do 1 plus 4 and then square the answer. So 1 plus 4 is 5, squared gives me 25. 1 plus 4, 2 plus 4 is 6, squared gives me 36. 3 plus 4 is 7, squared is 49. 4 plus 4 is 8 squared, gives me 64, and 5 plus 4 is 9 squared, gives me 81. So you can see that there are several ways in which we can do this, and in an exam, that generally speaking, if you write down the 5 correct numbers, you'd get full marks for it. You probably, if it's worth 3 marks, you might lose a mark for any incorrect terms you've written down. But mostly the method marks, because as you can see, there are several ways in which you can do this. There might be some method marks available, but generally speaking, it is possible, depending on the complexity of the nth term formula, you can do it in your head. So just writing down the right answer could in fact give you full marks as long as they are correct. So when finding the nth term of a quadratic sequence, it kind of works in steps. So the first thing we need to do is, and if I write down the steps in terms of here, so the method. So number 1 is, what you want to do is find the double difference. Now the double difference is simply the difference of the difference. So we find the difference of the difference. So here we've got the difference is 3, 5, 7 and 9. So working out the double difference, that's going to be plus 2. And obviously if this is going to be a quadratic sequence, then you'll find that the double difference is going to be the same number, which in this case it is. Then the next thing we then need to do is the double difference, or double diff, divided by 2, n squared will be in the formula. So just like with linear sequences, well, when you worked out the difference, that number n would be in the formula. Well, with quadratic sequences, the double difference divided by 2, n squared, will be in the formula. So here, as our double difference is 2, 2 divided by 2 is 1, which gives us 1n squared, which just leads to n squared. So what that means is that n squared is going to be in the formula. Now the next thing we then need to do, which is a little bit tricky, is then we need to work out the difference between the dd, which is double difference, divided by 2 n squared, and the first few terms. Now for this, what we need to do is set up the table. So if I set up n and 1, 2, 3, 4, 5, and we've got the numbers in the sequence, which are 7, 10, 15, 22, and 31, and let's just put some lines there, and that line there. And then what I then want to do is then work out what the n squared is. Now the reason why I'm using n squared is whatever this is, I'm going to put that here, and I'm then going to work out what n squared is. So when n is 1, n squared is going to be 1, 2 squared is 4, 9, 16, and 25. Now the next thing we then need to do, so what step 3 is then it's asking me to work out the difference between the third row and the second row. So to get from here to here, it's going to be very messy. So here I've got 1 to 6, I need to, 1 to 7, I need to add 6. 4 to 10, I need to add 6. I need to add 6, add 6, and add 6. And I'm kind of questioning my choice of colours because you can't really see it. Now, as these numbers are the same, then all we then need to do, so the nth term is going to be n squared plus 6. And there we've got nth term for this quadratic sequence. And so let's just finish up these steps. So work out the difference. So if the same, then join this, let's put that in brackets, join this to step 2 to produce your nth term. Now I'm just going to put a little asterisk there because obviously if these numbers here weren't the same, and when we go on through a few examples there will be a case where that isn't the same and what to do in that situation, then you'd have to have a look at going a little bit further, and that's probably where you'd go to a higher level question on quadratic sequences, which would easily appear on a GCSE paper, less likely to appear on a standard KS3 paper. So our nth term for this particular quadratic sequence is n squared plus 6. So moving on to our next sequence, so we've got -2, 4, 14, 28. So again, going through the steps, the first thing we want to do is work out the initial difference. So in this case, we've got plus 6, then we've got plus 10, then we've got plus 14, and then we've got plus 18, and then the double difference is going to be plus 4, plus 4, plus 4. So again, as these numbers are the same, it's a quadratic sequence. So then, as the double difference is 4, that means 2n squared is going to be in the formula. So I know that for a fact. So the next thing I then need to do is draw my table. So I've got n equals 1, so let's do these first. I don't know why the first line is always a little bit wonky. So we've got 1, 2, 3, 4, and 5. We've got the numbers in the sequence, and because I've got 2n squared in the formula, I then need to do 2n squared here. So filling in the numbers, I've got -2, 4, 14, 28, and 46. Now, to work out 2n squared, again, remembering that 2n squared means 2 times n squared, so you've got to do the n squared first and then times it by 2. So 1 squared, remembering that n are these numbers at the top row. It's very easy to get confused between the numbers in the other row. So 1 squared is 1, times 2 is 2, 2 squared is 4, times 2 is 8, 9 times 2 is 18, 16 times 2 is 32, and 25 times 2 is 50. So then what we then need to do is compare these blue numbers to the red numbers above. So here I need to take away 4, here I need to take away 4, and then I've added 4 there. So get rid of that. Okay. I need to add 4. There we need to take away 4, take away 4, and take away 4. And because all of these numbers are the same, then double plus, where that's come from. -4. So as you can see, the difference between our 2n squared and the numbers in the sequence are all the same. So the nth term in this case is going to be 2n squared minus 4. So now moving on to what I'm already going to give you a clue is a more complex example. So here let's have a look at what the difference is going to be. So between 4 and 1 I've got to add 5. Between 1 and 8 I need to add 7. 8 and 17 is plus 9. And then I need to add 11. So working out the double difference, it's going to be plus 2, plus 2, plus 2. Now again, you can have negative quadratic sequences, so just make sure that if the double difference was -2 or -6 or whatever, we'd go from there. Now also you might find that because your double difference is you divide it by 2, you might find that you might be working with fractions or decimals, but again that would be in very extreme cases and obviously classed as a much higher level topic. So from this, what we then need to do is our double difference is 2, so that means 1n squared or n squared is going to be in the formula. What we're now going to do is create our table, so let's get a different colour. So I've got n, I've got 1, 2, 3, 4, 5, and let's just make it look like a table. I've got the numbers in the sequence, which are -4, 1, 8, 17, and 28. And as n squared is in the formula, I know that for a fact, I then need to find the values of n squared as well first. I've got 1, 4, 9, 16, and 25. So from this, what I now need to do is work out the difference to get from this number to this number. So here I need to take away 5. Then I need to take away 3. Here I need to take away 1. Here I need to add 1. And here I need to add 3. So as you can see, that all of these numbers are different, where in the previous two examples they were the same. So if I now just call this the difference, I've got a sequence of -5, -3, -1, 1 and 3. And what you should be able to notice is that this is a linear sequence because, and the reason why it's a linear sequence is because if I worked out the difference between these numbers, I need to add 2, add 2, add 2 and add 2. Now from going back a stage, so if I just ignore that I said all of this and we'll come back to it. So from what I know is I've got n squared plus this difference. And that's what my nth term is going to be. Now the reason why I don't know what the difference is because the difference keeps changing. Now the difference from these set of numbers is a linear sequence. So if I then start off with n, so the first difference is, well, let's call this difference, might make a bit of sense. So the first difference was -5, the second difference was -3, the third difference is -1, the fourth difference is +1, and the fifth difference was 3. So from this, I know that the difference is +2, so 2n is going to be in the formula. And so then, how do I get from 2 to -5? Well, I need to subtract 7. So from this, I know that the formula for the difference is going to be 2n minus 7. Now if this is going to be 2n minus 7, then the nth term for this quadratic equation is going to be n squared plus 2n minus 7, and there is your final answer. So as you can see, with more complicated examples you might find the differences change, but that in itself turned into a linear sequence. So it's always worth just having that in mind, and finding a method and a structure that works for you will help decide what type of quadratic question it is that you're trying to find the nth term of. But I'm just making you aware that these things can change. Also look out for negative n squares, which make the whole process a little bit more difficult because you're dealing with negatives, so just be wary of that. And like I said, these are types of questions you can easily make up and create your own and try and work backwards, but there is plenty of variety for you to have a go at.